Okay, so today we're concerning ourselves with changing an equation that's in standard form, right? That's our standard form, and we want to change it to something that's in vertex form. This form is called the vertex, as it says here. It gives us the equation of the axis of symmetry as well as coordinates of the vertex. So the equation of the axis of symmetry is x equals h. The coordinates of the vertex are hk. If a is greater than 0, it opens up. You have a minimum of y equals k, and it occurs when x equals h. And if a is less than 0, it opens down, right? If it opens down, your vertex is a minimum. If it opens up, if it opens up, the vertex is a minimum. If it opens down, the vertex is a maximum. So these are the steps, and depending, like it says, factor out the coefficient of x squared, but if the coefficient is 1, we don't have to worry about it so much. Group the terms containing x. We'll complete the square. Remember, to complete the square, you have to add and subtract 1/2 times b, that guy. Once it's factored, it's not really b, it might be b divided by a. I'll get a more complete formula. I better not write it like that. But you have and square the coefficient of the linear term, and then you add it and subtract it, and you simplify and you come up with the vertex form. So these are the steps. I'll go through them with you in each example. Notice a equals 1, so that means we don't really have too much to factor there. Okay, so y equals, well, they say group the terms containing x. Well, they're already together and there's nothing else, so we'll leave it like that. So remember, have and square the coefficient of the middle term, and that will equal 4. So we add 4 and we subtract 4. The net effect should be adding 0. Once you add 0, then you're not changing the appearance of this graph of this equation. So this is going to be, here's our perfect trinomial square, perfect square trinomial. So we can factor that. Once you know it's a perfect square trinomial, and we know because we did this step, when you do that step, you know it's a perfect square trinomial. We square root of the first term, square root of that term, the third term of your trinomial. Since that's a plus squared minus 4. So can you tell me, what is the vertex? Yeah, x is minus 2, y is minus 4. Do we have a max or a min? We have a minimum of y equals negative 4. Right, we have a minimum because the parabola opens up. And it occurs when x equals negative 2. Okay, so that's that question. Do you feel you need me to do this one, or would you like this example? You guys decide. Agnes, would you like this example? Doesn't matter. Anyone want this example? Okay, so that's okay. If you want it, I'll do it for you. No skin off my bones, I'll tell you that much. Okay, a is equal to 1, right? So that makes it nice and easy. They say group the terms. Well, there's nothing to group. There's only the two terms. So we're going to have to complete the square. 3 over 4 we have, and we square it. And that's going to be 3 over 8 squared all over, and that's 9 over 64. So I'm going to move this over a little bit so it doesn't interfere. Always try to do your rough work onto the side. So it doesn't interfere with your mathematical, your logical work where one step flows, everything flows from one step to another. So it's going to be x squared plus 3/4 x plus 9 over 64 minus 9 over 60. So y equals, here's our perfect trinomial square right there, and we'll just leave that, we leave that off to the side because we don't want it to interfere with our perfect trinomial square. We don't drop it though, we have to include it. So we know this is a perfect trinomial square root of the first term, square root of the last term. Since that's a plus, that's a plus, and it's minus 9 over 64. So again, vertex negative 3 over 8 minus 9 over 64. This one opens up again, so the vertex is a low point. So we have a minimum of y equals negative 9 over 64 occurs at the x value, or at the axis of symmetry, right? Occurs at x equals negative 3 over 8. Can I explain anything better? Anything at all? Okay. Okay. So I'm going to let you do this one, okay? The answer to this is so you can check your work. The vertex, and we have min again, and it occurs when x equals negative 4. So you give that question a try later, and then you can check your work, okay? I don't want to do too many where a equals 1 because I don't want to insult your intelligence. Okay, let's do when a does not equal 1. Well, now we have to factor out a. Y equals 1/2 let's see, x squared. Oh, what do we have to write here? Okay, so to find out the number in front of x, we're going to divide by 1/2, so 3 over 1/2, and that equals 3 times 2 over 1 equals 6. So 6x, we'll keep that together, plus 2. Here's our rough work. Just try to box it off. It's hard to mark on test when you put your rough work right inside your logical flow of your answer. Always do it off to the side. Okay, now we can have and square the coefficient of the linear term. So it's 1/2 times 6 squared, and half of 6 is 3. 3 squared is 9. So it's plus 9 minus 9. Okay, we're going to have to kick that negative one number out because we don't want to interfere with the perfect trinomial square. So to get it outside the bracket, we multiply it by 1/2. And we'll get a common denominator so we can add them up. So again, we know this is our perfect square trinomial, so we know it's easy to factor, and we know that because of this trick with the halving and squaring of the coefficient of the linear terms. So we have a perfect trinomial square here, x plus 3 all squared, and that's going to be minus 5 over 2. So we have our vertex, negative 3 minus 5 over 2. It opens up, so again we have a minimum of negative 5 over 2, and it occurs at x equals negative 3. Can I explain anything better? Do you remember this from grade 10 a little bit? Yeah? Not really? No. Well, we'll just have to work on it then. Okay, so I'm going to give you the answer to this one, and I'm going to do this one. So the answer to this one is y equals negative 2 x minus 5 over 2 squared plus 11 over 2. Thank you. Yeah, just keep me on track, okay? So we have a vertex 5 over 2, 11 over 2. Our max is 11 over 2 occurs at x equals 5 over 2. So you guys do that question, okay? No, because I'm recording, so later. Okay, what should we do here? I'm going to do this one with you just because it's probably one of the harder examples. Tell me, what would you do first? Yep. Sounds good to me. So negative 2 divided by minus 1/3 equals negative 2 times negative 3 over 1 equals negative 6. So it's going to be negative 6x. We'll leave some space to complete our square. Sorry? Oh, sounds good to me. Thank you. Thank you for pointing that out. So now we need to have and square the coefficient of the linear term. So that equals 9, right? Plus 9 minus 9. So we're going to have to kick out this negative 9 out. We're just going to multiply it by negative 1/3 to move it. So we have nothing to interfere with their perfect trinomial square. We just want that in the brackets by itself. So this is going to be negative 1/3 x squared plus 6x plus 9 plus 3 plus 1. And that's negative 1/3 x plus 3 all squared plus 1. Vertex. And you know this opens down, so the vertex represents a maximum. For occurs when x equals negative 3. I have to show you one more way to find a vertex. It's the method of partial factoring. It's really different. All right. Partial factoring allows you to find the x coordinate of the vertex by using points that are equidistant. Okay, you can use these two values to find the x coordinate of the vertex. So I would say I'm just going to do a rough guideline here for the axis of symmetry. I mean, I could guess that that's x equals 5, but when we do it algebraic, when you determine something graphically, it's not as accurate as when you do it algebraically. So let's find the way we do it algebraically. So I think what I'll do is, what we want to do is, we want to find 2 points symmetric that should be a C. Symmetric about the axis of symmetry. So what we do is, we find 2 values of x when our function f of x equals 10. Where do you think we got the 10 from? Well, I guess is it that 10 or that 10? This one here? Yeah, this one here. So it's basically your C value. Okay? So what we're going to do is, when this function, the y value is 10, when the y value is 10, then we find the corresponding x values right there and right there. So when I have 2 values of x that are symmetric about the axis of symmetry, how do you think I find the axis of symmetry? Here, let's find the points first and you tell me what to do with. I'm going to find 2 values of x when this function equals 10. Can you see that x value, the distance there, equals that distance? Right? It's equal. They're equidistant about the axis of symmetry. So let's find those 2 x values algebraically. So f of x is 10 equals x squared minus 10x plus 10. So we subtract 10 from both sides. And now we're going to just factor this part of the equation. Just that. That's why they call it partial factoring. So 0 equals x times x minus 10. X equals 0 or x minus 10 equals 0, right? You're using the 0 product property. If x is 0, this is 0. If x is 10, this is 0. In this case, x equals 10, right? So, using these 2 points, 0 and 10, how do I find the axis of symmetry? How do I find the midpoint of those 2 points? Yeah? Perfect. X equals 0 plus 10 divided by 2. Right. Now, if I know the x value of my axis of symmetry, if I know the x value of my vertex, how do I find the y coordinate of the vertex? Can anybody tell me? If I know the x value of my vertex, how can I find the y value of my... Yep. Perfect. Sub in x equals 5 into sub x equals 5 into f at x equals x squared minus 10x plus 10. Now you might not be familiar with this kind of symbol. This is another way to write y, but if I were to write f at 5, all that means is wherever there's an x, plug in a 5. 5 squared. So that's 25 minus 50 plus 10, and that equals 15. So there's my x coordinate of the vertex, there's my y coordinate of the vertex. The vertex is 5 comma negative 15. Can I explain anything better? Yep. Oh, that should be negative. That answer's right. That one was wrong. 25 minus 50 is negative 25. Negative 25 plus 10 is negative. Thank you for pointing that out. Let's try one more. Just another example to reinforce it, and then we'll call it a day. Okay, use partial factoring to find the vertex of the parabola of the function f at x equals that. Okay, so to find 2 points symmetric about the axis of symmetry, let f at x equal what? What should I let f of x equal? 7, right? You pick 7. So we write, this is our original equation. So we write 7 equals So let's do it, and then we'll partially factor. Subtract 7 from both sides. Factor out. We'll factor. Our greatest common factor is negative 2x. So negative 2x equals 0, or x equals 0. X plus 2 equals 0. Or in other words, x equals negative 2. So now we average these guys to find the axis of symmetry. So we have this is the x coordinate of vertex, right? So now we can find, now we find the y coordinate. So f of minus 1 equals negative 2 times minus 1 squared minus 4 times minus 1 plus 7. So that's going to be negative 2 plus 4 plus 7. That's 2 plus 7 is 9. The vertex is negative 1, 9. Okay. I'm just going to